Hi, so today we're going to be discussing resistance. What are resistors? What a resistor does in an electronic circuit? What is impedance? What is the importance of this? How does this affect current and voltage? And this is one of the most basic building blocks of any electronic circuit. So if you don't understand how resistors work, you're pretty screwed. So that's why we're going to start with resistors. Now, this is one of those things where the explanation that you get from a basic electronics textbook actually makes sense. Or if you Google it and you look at Wikipedia, the way they explain you actually can understand it without having had to go to college. Resistors act to reduce current flow. It's just that simple. A resistor is a passive two-terminal electrical component that implements electrical resistance. Now, remember what we were talking about before? We were talking about the difference between voltage and current. Voltage is the potential to deliver the electricity, whereas current is the actual flow of the electricity through. Now, as I said, you cannot change the current going through a circuit without changing either the voltage or the resistance. So let's say you have a 12-volt circuit and you want to start getting more power out of that 12-volt circuit, you need to lower the resistance. So I'll show you how this works here with this basic Ohm's law calculator. Now, resistance is something that's measured in ohms. One of the things that you're going to notice about everything in electronics is that all the people involved in electronics, they're egomaniacs. They use their names on everything. So, amps was named after a guy named Ampere. Ohms was from the guy who made Ohm's law, who was named Ohm, and so on and so forth. So resistance is measured in something called ohms. So let's say I have 1.05 volts. Let me just zoom in over here so that you can see it, even if you're at low resolution. So you have 1.05 volts, and the resistance is 10 ohms. You're going to get this many amps. Now, if I lower the resistance to 5 ohms, you get more amps. If you up the resistance to, let's say, 1,000 ohms, you get a lot less power. You get this many amps. So the higher the resistance, the less current that you can have flowing through a circuit. And let me show you how this works on a basic schematic here. So over here you have 3.42 volts on this side, right? Now on the other side of this resistor, there's still going to be 3.42 volts, but you've limited the ability for current to go through that resistor. So you're kind of isolating what's on this side of the resistor from what's on this side of the resistor. So this is a 3.42 volt power rail. Let's say on the other side of the resistor that this were to short to ground on this power line. Without the resistor there, you would be shorting a main power line of the computer to ground. However, since there's a resistor here that limits current flow, and it's high in value, it's 2 kiloohms, let's see the maximum amount of amperage you can have on the other side. So it's 3.42 volt power line here, and that's a 2 kilo ohm resistor. So we're going to go back to our Ohm's law calculator. So we have a 3.42 volt line, and we have a 2 kilo ohm resistor. So kilo is 2000. You can either click kilo ohms here and go 2, and let's see. So the maximum amount of amperage you can have on the other side of the circuit is 0.00016, which is like 0.00053 watts, which is negligible power usage. And this is an important concept to understand. Because over here, we're trying to create a signaling line, which is something that I'm going to talk about in a future video. In the future video, I'm going to talk about how the resistor does it, why we use resistors to create data lines. But before we get into any of the cool things you can do with resistors, you have to understand a resistor's basic function. A resistor's function is so that you have less current on the other side of the resistor than you do on the starting side of the resistor. So the amount of current that can go through a resistor is very limited. Without a resistor, the current would simply run through it as fast as it could, and this is not the desirable effect most of the time. So that's pretty much that. Now impedance is a little bit different. So a resistor is, you measure the resistor's resistance, using the word resistance. So the resistance is measured in ohms. Now impedance is a little bit different. Impedance is you're taking the entire resistance of a circuit, you're combining the inductance, the capacitance, the resistance, every element of that circuit, and then you're giving that a value in ohms. So let's say I am measuring, let's go and measure something a little bit more complicated here, shall we? So let's go to a different part of the circuit. Let's go to, let's say, U7000. So let's say I put let's say I put one probe of my multimeter over here, let the black probe over here, and I put it in resistance mode, and then I put the other probe of the multimeter over here. So, there are capacitors over here, there's a fuse, there's a current sensing resistor, and there's an inductor. So there's a lot of different there's a lot of different things going on here. You wouldn't call that the resistance of the circuit, you would call it the impedance of the circuit, because there's a lot more going on there than just basic resistance. But impedance can be measured in ohms the same way that resistance is measured in ohms. And this is another thing that's important to understand here, is that you can tell when a circuit is working the way it's supposed to. Or for example, let's say that this thing is destroyed, right? You may get a different value when measuring the impedance of that circuit than you would if this was working. So understanding how resistance and how impedance measurements work, and also keeping a little Excel sheet for yourself of when a circuit is working, of what its impedance to ground is, of what the impedance is between different points in a circuit is on a working board, can help you troubleshoot a bad board. So instead of having to replace every single component and test every single component and every single part of the circuit, you could just make quick measurements to narrow down what's actually going on. So that's what a resistor is. A resistor simply resists electrical flow. It simply resists the current going from one side to the other. So the voltage will be the same. It doesn't matter if you have a 1 million ohm resistor and you have 12.6 volts on one side, you're still going to have 12.6 volts on the other side. But the current will be limited through the resistor because the resistor is resisting the current flow.